Hello, everybody. Today we're going to be going through how to convert hexadecimal numbers into decimal. So, with this conversion, right, I've got a table on the right here comparing hex numbers, or at least 16 powers with their decimal equivalents. So you've got 16 powers under hexadecimal, which is base 16, and you've got the equivalents in decimal, which is in base 10. So there you have it. Apart from that, I've also included in the key for the alphabets that come in as part of the hexadecimal number system, because as you know, hexadecimal number systems are a little bit special in the sense that it uses up all the 10 digits from the regular decimal number system, and uses the first six letters from the alphabet system to fill up the remaining six at the very end. So yeah, let's get started. So with this one here, let's try to convert this number right here. We're gonna want to resort to using a table to plot everything out. So we're looking at three places here. So 111 base 16. We're putting in each digit in this hexadecimal number in each slot at the bottom. And then from here, we're going to want to count up the powers, from right to left. For we're counting up the 16 powers essentially. So from the right, you're putting in 16 power 0, 16 power 1, 16 power 2. Now from here, what you have is this. You're going to want to consider each pair, like as shown right here. And then from then, all you're doing is simply multiplying whatever number that you've got down here, and multiply it by the number that corresponds to it on top. So in this case, your first line of looking should end up looking something a little bit like this. 1 multiplied by 16 power 2. I'm bracketing this up. I'm putting them up in parentheses, just to show the distinction between each of the number places inside. So 1 multiplied by 16 power 2 plus 1 multiplied by 16 power 1 plus 1 multiplied by 16 power 0. Then from here, you're going to want to in practice, refer to this small table right here, to find out their decimal equivalents. If you were able to sort of just remember this by heart, then that would be very helpful, to be very frank. But if not, especially with practice, it doesn't really matter. It will come in naturally as you go, with more practice and all. So okay, let's go ahead and substitute each of these 16 powers with their decimal equivalents. 16 power 2 is 256. 16 power 1 is 16. Anything to the power of 1 is just the number itself, just fun fact. And another fun fact, anything to the power of 0, in this case 16 power 0, will always result with 1. So from here, it's a lot more on just simple arithmetic. Trying to just solve these questions here now. One multiplied by 6 is 256. 1 multiplied by 16 is 16. 1 multiplied by 1 is 1. So in the end, you should get 273. 273, sorry. And in this case, if you want to be a stickler with the base number, you can put in base 10 right here. But it's universally understood. If you don't put in any base number at the back, being the subscript down there, it's immediately understood that it's just a regular decimal number. All right, a regular schmegular decimal number. Okay, now with the next two examples here, we're dealing with having some hexadecimal numbers, which requires the use of this key right here. So yeah, again, we're going to resort to just using the table right now. Again, there are three places altogether. Hold on, let me just make this a little bit smaller. Okay, so from here, you put in A and 1 and 2. base 16. So again, you want to put it from right to left in increasing 16 powers. So 16 power 0, 16 power 1, 16 power 2. Now, before you head on with writing out your first line of working, you're going to want to consider if there are any of these letters that are being used, inside this part right here. In this case, we've got an A right here. So with this one, by referring to the key down here, we know that A is essentially 10. So we can just hold on. Let me maybe I shouldn't erase that. This one here is just simply 10, right? Or maybe perhaps maybe erasing is right, just to keep it neat sake. So yeah, this is just 10. So let's go ahead and start writing our first line of working. So in here, if you want to write down the hexadecimal letter in the first place later on without needing to do something a little bit like this, it's also fine. How it will end up looking like, it'll look something a little bit like this: a multiplied by 16 power 2 plus 1 multiplied by 16 power 1 plus 2 multiplied by 16 power 0. It looks a little bit jarring, you see. So this is not something that I personally find comfortable doing. But if it helps, then so be it. But otherwise, regardless, you should have a line that looks something a little bit like this. Whether you start off with writing this as A, or you proceed on with the next line being something like this, or the like. Okay. Then from here, you're just going to want to replace each of these 16 powers with their corresponding decimal equivalents. So 10 multiplied by 16 power 2 is 256 plus 16, no, 1 multiplied by 16 power 1 is 116 plus 2 multiplied by, okay, 16 power 0 is just 1. So in the end, you should get 2,560 plus 16 plus 2, which all in all, you should get 2,578. There you go. This is your answer for part B. Now for one more practice sake, we're gonna deal with another hexadecimal number. This time, two of the digits being used here require use of this key right in here, since they're just essentially just the letters, in the hexadecimal number system. So again, we're gonna resort to the table again. So A, D, and 5, base 16. And then I'm going to want to count up in 16 powers from right to left. 16 power 0, 16 power 1, 16 power 2. And now before we write down the first line, we're going to want to pair up, or at least, no, not pair up, replace the given hexadecimal values that are in here. So A is essentially 10. Yeah, A is essentially 10. And D is essentially 13. 13 right here. So this is enough information for us to get started with our first line of working. So let me just bring this down a little bit to make this a little neater. Okay, so the first line should be 10 multiplied by 16 power 2 plus 13 multiplied by 16 power 1 plus 5 multiplied by 16 power 0. And from here, gonna want to replace all the 16 powers with their decimal equivalents, as like with the previous two examples. So 16 power 2 again is 256. For the most part, if you're dealing with 8-bit registers, usually around here is about enough. But given how it is with your questions, your mileage may vary. I'm only listing up to 16 power 3. But if there's anything, if at any point that you need something larger, you can always just multiply each time by 16. That's how the system sort of works with this key right here. So again, 16 power 2 is 256. 16 power 1 is just 16. 5 multiplied by 16 power 0 is just 1. So you should get 2,560 plus. Now for this one is equal to a, just gonna cheat here, 13 times 16 is equal to 208. 208 plus 5. So from here, your answer should end up being 2773. So there you go. This is your answer for this question. AD5 base 16 is equivalent to 2773 in the decimal number system. And there you have it. This is how you convert hexadecimal numbers into decimal. I hope it's been helpful, and thank you all for watching. Also, signing out.